Okay, let's talk about pandas and how we're going to do this work of cleaning our data responsibly. So pandas, one of the most widely used and important data science packages for Python or for anything. It works a lot like SQL in that it is a declarative language. In other words, we are telling Python what to do but not how to do it. There's imperative code that exists underneath the hood that we don't have to work with, but that imperative code in Python is written in NumPy and other programming languages like C in order to run all these functions as quickly as possible. So defaulting to pandas to do data management is a good idea because in most cases it's also going to be optimized for speed. The goal, our goal, is to use pandas to turn raw data into tidy data. And we've talked a little bit about tidy data in the notebooks, but just to review what that concept is. Hadley Wickham, who is the founder of RStudio, he wrote a really influential article in the Journal of Statistical Software where he defined tidy data as data in which the rows are either records or observations, whatever word you like. The rows are like units, so that every row is a person, or every row is a country, or every row is a time point, and you don't mix up the units across the rows. And also the columns are your features. All the data exists in one table, so if you have different tables, then you join them together so that you have just the one table. And then you use the fundamental verbs of data manipulation: filtering, sorting, transformation, and aggregation. So we're going to talk about what all of those things mean in just a second here. Pandas can do all of these, and once you get comfortable with pandas, then you can handle any kind of messy data set. It's a really, really great tool. So the first thing that we need to know about working with data with pandas is how to understand the data, how to diagnose problems. So we have the raw data, and it's just sitting there in Python's memory, and we don't necessarily know what to do with it, right? So what we need are tools to see the data, to wrap our heads around the problems. So the first tool is .info applied to a data frame. This object here, ANES, is an example data set that I talk about in the notebook. It's a study of voters in the United States just prior to the election. And this is the most recent one. So you're going to see people's opinions here about Joe Biden and Donald Trump for the upcoming election. So info tells you a bunch of stuff. It tells you the index, which is the row numbers in this case. It's going to tell you the number of rows by looking at the number, the range of the index. It's going to tell you the number of columns. It's going to give you a count of the different data types, column to column, and it's going to tell you the amount of memory that this particular data frame takes up. It's always a good first thing to look at. Now, the most important way to see the data is to quite literally see the data frame. If you type the data frame into a cell and you execute that cell in your notebook, the data frame appears. But they're going to be dots, right, that cut off the number of rows or cut off the number of columns. I suggest turn off the limit on the number of columns that can be displayed, but leave the limit on the number of rows, because you could have thousands and thousands of rows or more than that. But the columns, you want to be able to see the columns. So I suggest set option display max columns none. And then you can use methods like head and tail, and you'll be able to see all of the columns. That's going to give you a sense of what are the values and what you need to do to those values. And then there's describe. Describe we talked about in module 2, so you could go back and look at that, but it reports summary statistics. So you could think about what are the numeric characteristics of a column that you're working with, and then when you use describe, you could see if it matches our expectations. And if it doesn't match, Like, for example, if the minimum or maximum value is crazy small or crazy big, some value we don't expect, that will clue us into the fact that there is something we need to do to clean the data. If we want to see the data type of each column, we can use the dtypes attribute. We also talked about that in Module 2. If we wanted to see all of the data types, we could temporarily set the max rows to none. No maximum on the number of rows that can be displayed, but then be sure that you set it back to 10, which is the default. If you want to see any rows that are duplicated, you can use the duplicated method, which will give a logical series that goes row by row, whether this row is a duplicate row or this row is not a duplicate row. If you wanted to see the rows themselves, you could use the LOC attribute, which allows you to call specific rows. We'll talk more about LOC in just a second. If you wanted to remove the duplicated rows, you just put a tilde in front of duplicated. Now, be careful when you are duplicating rows. Think about why are there duplicate rows to begin with. There's not a set in stone answer for why you might have duplicated rows. It's important to think about the data source and to refer to the documentation if there is documentation, to try first to understand why are there duplicated rows. Only do something draconian like removing them all in one fell swoop if you're sure that it's safe to do it. Okay, we can take a look at value counts and we can take a look at a frequency table. So these two report a count of a categorical variable, category by category. So for this one, vote 20 canned, we have 419 who chose 1. Now, what category 1 means in this case, I don't know. I have to look at the code book, and that's part of what we're going to be doing with this data. The difference between value counts and STB freak is that STB comes from another package called side table, and it reports the percents and the cumulative counts and the cumulative percents. It's just a nicer version of value counts. Okay, indexing. When we want to index a data frame, it means that we are trying to pull out a selection of rows or a selection of columns. Now, one way to pull out a single column is to call the name of that column as an attribute. So we want the feeling thermometer score for Joe Biden, voter by voter. So we could say ANES.FT Biden, and that pulls out that column. Or we could say ANES and then brackets and then FT Biden in quotes. Both of those are exactly the same. Now, we can extract more than one column with that second approach, right? But instead of one pair of brackets, we can include 2 pairs of brackets. What that's saying is we're passing a list to the data frame index. So here we're passing a list, FT Biden, FT Trump, and then that reduces the data to just the feeling thermometer for Biden and the feeling thermometer for Trump. If we want to refer to specific columns or rows with their row number and column number, then we use ILOC. So you write the data frame and then ILOC as an attribute, and then you can specify the row numbers and the column numbers. It gives you the option to use a colon to represent the range. So if I want rows 1, 2, 3, and 4, I could write 1:5. Remember, in Python, the upper bound is not included, but the lower bound is. And then the 12th, 13th, and 14th column, right? Or instead of using the colon, I could pass lists. So this gives me rows 2, 4, 6, and 8, columns 20, 25, and 30. That's what iloc does. I don't use it very often because very rarely am I referring to rows and columns with their number. Much more frequently, I'm using the names of the rows or the names of the columns. So in this case, instead of iloc, you use loc, just .loc. So if you type a colon in the first spot within those brackets, that means give me all the rows, and then comma, and then give me all the columns beginning with FT Trump and going through FTPALES, which is the feeling thermometer for the state of Palestine. This is a really interesting data set, and they asked people, how do you feel about this country and that country? So yeah, lock for referring to specific names, ilock for numbers. Now, the first thing I do when I clean data is I select columns. The easiest way to reduce a data frame is to include just certain columns. So in the ANES there are 900 columns, and I only want to work with a couple dozen. So what I do is I create a list of the columns I actually want, and then I just pass it as the index to the data frame. That simple. There are a few more specific things we can do. So if I wanted all of the columns that began a certain way, like with FT for the feeling thermometers, then I could use the method .columns.str .starts with and pass that to lock. So what this is going to do, remember lock captures columns by their name. It's going to give me all the columns that start with FT. There are other ways to select columns that give you more control, but are a little bit more technically advanced. I strongly recommend practicing with comprehension loops on the columns attribute of the data frame. So remember, a comprehension loop loops across elements of a list. In this case, we're going to loop across elements of the column names. And so I want to extract the column names that start with FT but do not end with timing and do not end with skip. And that gives me this selection of columns right here. And then I can pass this to the data frame. And then the last thing, say I type in some columns by hand, and I call that my calls. And then I use the FT calls list that I defined above, and I want to include both of them in one call. Then I could just add them together like this. The addition sign applied to two lists, it appends the two lists together. So it's one long list that contains both of those two lists. And then to drop a column, we use the drop method. So there was this column input state that I decided I no longer needed. So I just do ANES clean is my working version of the data. I apply drop input state. Now when I say axis equal 1, that means this is a column. If I were to write axis equals 0, it would mean a row, but this means a column. To rename columns, I use the rename method, and I pass a dictionary. The dictionary has the old name as the key and the new name as the value, right? So I want to change particip3 to protest. I want to change vote 20JB to just vote. And again, note that I have to write axis equal 1 because I'm renaming columns, not renaming rows. Now, let's talk about categories. I can relabel the categories of a single column by passing the dictionary to the map function. So I create a dictionary replace map. In that dictionary, I have the numeric value and then the label that's going to go onto it, right? So 1 is going to be labeled with Trump, and 2 with Joe Biden, and 3 with somebody else, and so on. And then I apply it to a particular single variable, vote, so ANES clean .vote.map, and then passing that dictionary. Now, this method can also be used to collapse several old categories into new ones. So I have this column in the data, ideology, which had values -7, 1, 2, 3, 4, 5, and 6. Well, -7 and 6 were like, don't know, and I skipped the question. So I want those two to be missing. For those two, I'm going to replace them with np.nan. It's a missing value that comes from NumPy. And then I want 1 to be liberal, but 2 to also be liberal. So 1 and 2 are going to be collapsed into the same category now. 3 to be moderate, and 4 and 5 both to become conservative. and then I can use map the way I did before. If I have many features that are all categorical and I'd like to label their categories in one fell swoop, then I could create a replace map that contains dictionaries within dictionaries. So first I could say, all right, this column, live urban, and then it's equal to this dictionary that maps what categories get labeled how. And I do that for all of the columns, vote 16, conf econ, party ID, that I would like to replace. I save it all as one Python variable, replace map, and then I use the replace method, not the map method, the replace method. I pass it the replace map, and now all of these columns are now labeled. Okay, one last point before we conclude this discussion on categorical data. It's very easy to make mistakes here. We could mistakenly place a wrong labels on the wrong categories. And if we do make that error, Python will not give us an error. It'll just let us proceed. And we might think that everything's okay. But if we made the mistake that Baggerly and Combs identified, say we swap the 1 and the 2, then we could corrupt the entire data project. You have to be extremely careful here. Read the code book. Make sure that you've labeled these categories correctly. Right, here's just an example. If you swap the 1s and the 2s, everything in your machine learning model will report the opposite of the truth. So be very, very careful. We change the data in significant ways when we do this. And so we have an extra responsibility to be extremely transparent with all of these changes.